So today we are just going to be talk about the angle properties and circle theorem. But before we have to be go for the angle properties, we need to be discuss about some basic things about a circle. Maybe most of them you already know, but let's see how to discuss. Just 10 minutes. So now this is a circle. Yes. Can you please tell me what is this boundary is known as?
The circumference.
That is the circumference of a circle. Just a minute. Circumference. And if we are going to be take a line that is passes from the center, that is known as, yes, a line that is start from circumference, passes from the center and ended at circumference as well. That is
The
known as,
diameter.
that is the diameter of a circle. All right. A line that start from the center and ended at circumference, it is known as, yes, Daniel, it is. Yes, Daniel, are you here? Yes, Salim,
Yes, sir.
it is.
That's radius.
Yeah. So the distance from the center to circumference, that is known as radius. All right. A line that starts from circumference and ended at circumference but not passes from the center. That is known as,
A chord.
that is a chord. All right, Daniel. All right. So yes, Daniel, are you here? Not sure Daniel is here. Okay. If we are going to make a line that is passes for the center, it is diameter. And obviously, it is going to be divide a circle into two equal parts. It is going to divide a circle into two equal parts, and this half part is known as,
Uh, a sector.
that is known as not sector. It is semicircle. It is the half circle is known as semicircle. All right. In the same way, for example, if I'm going to make a circle and I'm just going to make a chord here that is from A to B. What is it? What it is?
Sir, an arc.
It is an arc. It is smaller one, so it is known as minor arc, and it is known as, yes, the bigger arc is known as
A major arc.
major arc. And let's have to take the same circle again. Okay. When you have to make an arc, so obviously The circle is going to be divided into two portions. When it is diameter, it is going to be divided into two equal portions, that is known as semicircle. And when you are going to be make a chord, so it is going to be obviously the both portions are different. So this is known as, yes, this portion is known as
A sector.
segment. It is known as, not segment. It is a smaller segment, so it is known as minor segment. In the same way, it is a bigger one. So it is known as minor one. And it is major segment. All right, so let's say it is a sector circle. You are going to be draw two radius. You are going to draw two radius. Because of two radius, you will get this type of portion.
Sir,
Yes.
sorry I couldn't talk. Sorry.
All right.
There was noise around me.
Okay. All right, no problem. So look at here, we have this portion, and you are going to draw two radiuses. So you will get this type of portion. And this portion is known as, yes, Salim?
Sir, an arc.
It is sector. A smaller one is known as minor sector, and this bigger one is known as
Major.
major sector. Yes, everyone. Any question up to here? These are very basic things, not circle theorems. They are the very basic things about circle. Any question up to here?
No, sir.
All right. After that, we have to be understand about the subtended angle. For example, you have a circle, and I'm just going to be take any 2 points on the circumference. So I'm just going to be draw a circle on the angle on the circumference. So this is the angle that is subtended from AB. You can say that it is subtended from AB arc, AB chord, or AB segment. So all of these versions are going to be exactly same. Okay. This is the subtended angle from AB chord, AB arc, or AB segment. All of these versions are exactly same. It is clear? Yes, any question up to here?
No, sir.
In the same way, if you are going to be draw an angle at the center, it is also the subtended angle. It is also the subtended angle from arc. This is subtended angle is known as A is central angle or center angle. And B is, it is on circumference, so it is B is circumference angle, or it is known as circum angle. Both are subtended angles, okay? Subtended means you are going to be subtended angle from arc AB or chord AB or segment AB. Okay, one is on the circumference, so it is known as circumference angle. If it is on center, so it is known as central angle. Yes, everyone. Any question up to here? Because these are the basic things that we need to be do the circle properties. Yes, Salim and Daniel. Any question up to here?
No, sir.
No, sir.
All right. Now we have first theorem. The first theorem is if you have a circle and you are going to be draw and you have the let's say you have 2 points A and B. You are going to subtended an angle at center, and from the same arc you are subtended the angle at circumference. The relation between these two angles are the central angle is going to be the twice of circumference angle, or in other words, the circumference angle is going to be the half of central angle. For example, I'm just going to be draw. I can draw angle like this, and I'm going to be drawing an angle here. Look at here, the same thing. It is at center and it is at circumference. For example, if it is going to be the central one is going to be A, so it will be yes. If I will say that the central angle is A, what is the circumference angle?
Sir,
So,
A
yeah.
by 2.
A by 2. It will be the half. This is the first theorem. All right, now I'm going to be write some observations and conclusions from there. And that is going to be helpful when you are going to be do the questions. So observations is two angles are being subtended by same arc. Okay, not different arcs. This is the important thing. They are subtended by same arc, one at center and one on circumference. If you have to see this thing, so from here you can make a conclusion. You can make the conclusion. The conclusion is center angle will be twice as that of on circumference. Or in other words, we can say that circumference angle will be half as that of center angle. Yes, the first theorem is clear.
Yes,
Yes.
yes, sir.
Okay, I'm just going to make just some different shapes so you're not going to be confused. Look at here. I'm going to make a, it is center. I'm going to be this angle. So you have to look at, they are both are started from A to B, same arc, and ended, one is at center and one is at circumference. For example, if it is going to be 60 degree, but then what it will be?
30.
It will be 30. Okay, so you have to look for the points if the both angles are subtended from the same arc or same segment or same chord. So one is at center, one is on the circumference. So the relation between these two angles is the central angle is twice than or double than the circumference angle. Or in other words, the circumference angle is going to be the half of central angle. This is your first theorem. Yes, it is clear.
Yes.
Now we have theorem 2. The theorem 2 is, for example, if you have a circle and there is a diameter, the property is if you are making any angle from diameter, or in other words, you are making any angle from the semicircle anywhere on the circumference, that always be 90 degree. That always be means the subtended angle from the diameter on the circumference is always be 90 degree. Doesn't matter where you are going to be making from. For example, I'm going to make another circle. It is a diameter. Let's say I have to make different one. I'm going to make this one here. It is 90 degree. I'm just going to make an angle here. It is 90 degree. I will make the angle here. You have to make the angle here. So if you have the making an angle from diameter to the circumference, that always be, there is no need to be by here. That always be 90 degree. Yes, it is clear. Yes, Salim Daniel. It is clear.
Yes.
Yes, sir.
So the observation is angle being subtended by a diameter or semicircle anywhere on circumference. The conclusion is then the conclusion is this angle will be, yes, this angle always be, yes, sorry. If the angle is subtended from diameter on the circumference, it is always be
90 degree.
90 degree. This is your second theorem. Yes. Any question up to here?
No, sir.
Now let's we have to go for the third theorem. Theorem 3. Theorem 3 says that, for example, if you have a circle, there is a segment AB, you are subtended an angle on circumference. One is going to be here, let's say one is going to be here, let's say we have to draw one is going to be here. So look at here, all of these angles are subtended from the same arc, right? The relation between these angles is they are going to be equal. It doesn't matter at which point on circumference they are going to be subtended. If these angles are subtended from the same arc or from the same chord, so on the circumference, anywhere on the circumference, so they are always equal. It is clear? Yes, sorry, Daniel. This property is clear?
Yes, sir.
Yes, sir.
All right, so we have the observation. Observation is two or more angle are being subtended by same arc or chord or segment on circumference, then the conclusion is, yes, what is the conclusion? Yes, what is the conclusion?
So the angle that is subtended from the same segment is the same.
Yes. Angle subtended on?
The same like segment.
Yeah. Circumference is would be same. All right. You can use the word segment as well. This is your third theorem. You have look at here, it is subtended from the minor arc. Okay, for example, if you are going to be making an angle, some of the students are going to be confused. For example, if it is a circle and I'm going to be draw a angle here. So look at here, it is subtended angle from AB, but it is subtended angle from the arc, major arc AB or major segment AB. Okay. So look at here, it is subtended from the major arc AB. So it is going to be subtended for, obviously it is not going to be equal to this one, because the green one is the subtended angle from the minor arc. On the other hand, the blue one means the angle A is going to be subtended from the major arc AB. On the other hand, B is subtended on the minor arc AB, so A and B will not be equal. Okay, you have to look for they are going to be subtended from the same segment, from the same arc. Clear?
Yes.
Okay, these are the three theorems. Before we have to further for the theorems, we have to discuss one thing about the quadrilaterals. We have done it, but I will discuss it again here. That is cyclic quadrilateral. Cyclic quadrilateral. Yes, what is cyclic quadrilateral? Yes, any idea what is cyclic quadrilateral?
The a coordinator that lies have all its four sides like the verticals on the circumference of the circle.
Yes, you are talking about circle properties. The circle property is if the all the vertices on the circumference is that is quadrilateral is known as cyclic. But what is cyclic? The question was what is cyclic? The cyclic is if the sum of opposite angles is equal to 180 degree. In a quadrilateral, the sum of opposite angle is equal to 180 degrees. That type of quadrilateral is known as cyclic quadrilateral. So if in a quadrilateral, the sum of opposite angle is equal to 180 degree, such type of quadrilateral is known as cyclic quadrilateral. Clear? It is just a property of cyclic. Now we have to go for the theorem 4. Yes, you have to tell me exactly correct. In the theorem 4 is if you have a circle and there is a quadrilateral, if all the vertices of the quadrilateral is on the circumference, if all the vertices of a quadrilateral is on the circumference, then the property is that quadrilateral will be cyclic. Means the sum of these two angles is going to be means if I you know it is A, it is B, so their sum must be equal to 180 degree. In the same way, the sum of these two, let's say it is C and it is D, so the sum of these two must be equal to 180 degree. For example, if it is going to be given that it is 70 degree, so it must be 110 because 180 minus 70 that would be 110. Clear?
Yes, sir.
So the observation is if all four vertices of a quadrilateral are on circumference, then the conclusion is yes, what is the conclusion?
Sir, the opposite angles of a cyclic quadrilateral are
Yeah,
always sum to 180.
a quadrilateral would be cyclic, quadrilateral. Means opposite. Yes, if the sum of two angles are equal to 180, these angles are supplementary angles, right? We have done it in the angle properties. If the sum of two angles is equal to 180, that angle, these angles are known as supplementary angles, all right? Or their sum is equal to 180 degree. Yes. Any question up to here?
No, sir.
We
Yes,
have
sir.
8 properties of a circle. We have done 4 properties in today's class. Inshallah, we are going to be do the rest of the 4 properties in the next class and do the topical questions. All right. After doing completing these questions, we have to start the questions. Just give me a 1 minute. I'm just going to be add some questions. These are not the topicals, it's just a bookish questions, but you have to be try it. All right. For example, look at here. We have done the property that if the angles are subtended from the same arc, they are going to be equal, right? Look at this one. This angle and this angle is subtended from the same arc, right? Yes, can you see the screen?
Yes, sir.
Look at here. This is the highlighted arc. The angle 30 is and the angle B are subtended from the same arc. And we have done the property if the angle is subtended from the same arc on the circumference, so they are equal. So we can conclude that angle B will be equal to 30 degree. Clear? Starting and Daniel, it is clear.
Yes, sir.
Yes, sir.
Same way, look at here. Look at this arc. It is subtended from. It is a subtended angle from this arc that is 27, and angle A is subtended from the same arc as well. So we can conclude that the angle A is equal to 27 degree as well. Clear? But inshallah, in the next class, we are just going to be to practice more. Look at here. In this one, this is the subtended on the center, and from the same segment, it is subtended from a circumference. Yes, what is the relation between these two angles? Between the central angle and circumference angle?
The angle at the circumference is half of the one in the
Yeah.
center.
So that will be equal to 84 divided by 2. You will get 42 degree. Yes, everyone. Any question up to here?
No, sir.
Before the next class, you must have to revise the properties. And inshallah, we are going to be do the remaining theorems. And we are going to start the topical questions.